Welcome to Ask and Learn.
So we have a ball which is dropped from a height of 2 meters, and this is the ground level, and then it bounces up to a height of 1.5 meters. And they're asking what is the fraction of the initial energy lost during this whole process. So the fraction of the energy lost, E lost, is equals to E initial minus E final, and the fraction which is lost is equals to E initial minus E final divided by E initial. And the energy initial is basically gravitational potential energy, so it is mg y initial minus mg y final divided by mg y initial. So in this case, we'll have this mg and this mg and this mg cancels, and you're left with y initial minus y final divided by y initial. And plugging in the equation, we get 2 minus 1.5 divided by 2. That gives you 0.25, and that gives you 25% energy is lost during this bounce here. So in the next part of the problem, they're asking about if the ball is dropped at this point, and this is the ground level. So what is the ball's velocity just here at this point, just before it hits the ground? That is the question they're asking. What fraction, and then what is the ball speed just before and just after the bounce? So just before, which is v before, so the ball has got here the energy half mvb squared. At this point, it has got, dropping from a height of 2 meters, we have got mg y initial, and we'll equate the two energies here. So we'll put this energy equals to this energy. So we'll have mgy initial is equals to half mv just before squared, and this cancels, and we get vb squared is 2gy initial. So vb squared is 2gy initial, so vb is equals to square root of 2gy initial. If you plug in the value of this, you will get 2 times 9.8 times 2, and that gives you 6.3 meter per second right at this point, just before squared is 6.3 meters per second. Then they're asking what is the velocity just after the bounce, which means that the ball is here, and now it bounces back to a height of 1.5 meters, and the velocity just after the bounce on its way up. So v after here, they're asking. So the kinetic energy at this point is half m v after, I'll say. Sorry, this should be a. So v after squared, and the potential energy at this point is mg times y final. So if we equate these two energies, so we'll get mgy final is equals to half mv after squared. So m and m cancels, so we get v after squared is equal to square root of 2gy final. And if you solve that, you will get square root of 2 times 9.8 times 1.5. Now it's bouncing to. If you solve that, you will get 5.4 meters per second. Well, there is energy lost in this whole process. So the energy is lost when the ball bounces, appears as heat. And because the temperature of the ball on the ground would have increased slightly after the bounce, definitely. Some energy may have lost because of sound energy, sound waves, and some may have been lost due to the non-elastic deformation, the deformation of the ground. So these are the three ways in which the energy lost appears, basically.